Many people believe that 6 hours of sleep is perfectly normal. It doesn't sound extreme. It's not 5 hours, which clearly feels too short, and it's not 7 or 8 hours either. 6 hours sits somewhere in the middle. For millions of people, it feels like a reasonable compromise between sleep and a busy schedule. But from a neuroscience perspective, 6 hours of sleep creates a very unusual situation. Inside the brain, it is not short enough to feel like severe sleep deprivation, but it is often not long enough for the brain to complete all of its nightly recovery processes. In other words, 6 hours of sleep places the brain in a subtle but persistent state of partial recovery. And that is why many sleep researchers call it the dangerous middle ground. To understand why, we first need to look at how sleep actually works. Sleep happens in cycles. Each cycle lasts roughly 90 minutes and moves through several stages: light sleep, deep sleep, and REM sleep. Deep sleep is responsible for physical recovery and neural maintenance. During this stage, slow brain waves dominate and the brain begins clearing waste products that accumulate while we are awake. REM sleep serves a different purpose. It plays a critical role in emotional regulation, memory processing, and the integration of complex information. Over the course of a full night, the brain typically completes 4 to 6 of these cycles. Each cycle contributes something different to brain function. Early cycles contain more deep sleep, which helps repair the body and restore neural systems. Later cycles contain longer REM periods, which support learning, emotional stability, and creativity. When sleep duration is shortened to around 6 hours, the brain often completes only 4 cycles. This means the final REM-heavy cycle is frequently shortened or missing entirely. At first, this might not feel dramatic. Someone sleeping 6 hours may still wake up and feel capable of going through the day, but small neurological differences begin to appear. In controlled sleep studies, participants restricted to 6 hours of sleep show gradual declines in sustained attention and cognitive flexibility. These changes are often subtle. Reaction times become slightly slower, concentration becomes more difficult during long tasks, and small mistakes appear more frequently. Interestingly, participants often believe they are performing normally. The brain adapts to mild sleep restriction in a way that hides the true level of impairment. Researchers sometimes refer to this as sleep restriction. Blindness. People cannot easily detect how much their performance has changed. Another important system affected by 6-hour sleep patterns is emotional regulation. The brain's emotional center, known as the amygdala, becomes more reactive when sleep is shortened. At the same time, communication between the amygdala and the prefrontal cortex becomes weaker. This connection normally helps regulate emotional responses and maintain rational control during stressful situations. When sleep is shortened, emotional reactions may become stronger while regulatory control becomes slightly weaker. This can lead to increased irritability, faster stress responses, and reduced emotional resilience. Again, the effect is often subtle. Someone sleeping 6 hours may not feel obviously sleep deprived, but they may notice that small frustrations feel slightly more intense. Sleep also plays a major role in memory formation. During sleep, the hippocampus and neocortex cooperate to reorganize the information gathered during the day. Important experiences are stabilized and integrated into long-term memory networks. Less important details gradually fade away. Deep sleep strengthens neural connections related to learning, while REM sleep helps integrate emotional and contextual information. When sleep duration falls to 6 hours, the brain may lose part of the final REM stage that normally supports these processes. Over time, this can make learning slightly less efficient. Students who consistently sleep 6 hours often require more repetition to retain information compared to those who sleep longer. Another system strongly affected by sleep duration is the brain's cleaning process. While we are awake, neurons produce metabolic byproducts that must eventually be removed. During deep sleep, a specialized fluid circulation system called the lymphatic system increases its activity. This system washes through brain tissue and helps remove waste molecules that accumulate throughout the day. When sleep duration is shortened, this cleaning process may not operate at full capacity. 6 hours of sleep usually allows some lymphatic activity to occur, but it may reduce the time available for this nightly maintenance. Over long periods, incomplete recovery can contribute to mental fatigue and reduced cognitive efficiency. Hormonal balance is also influenced by sleep duration. Sleep helps regulate hormones involved in metabolism, stress response, and appetite. When sleep becomes shorter, cortisol levels may remain elevated longer during the day, increasing physiological stress. At the same time, hormones that regulate hunger can shift in ways that increase cravings for calorie-dense foods. People who regularly sleep 6 hours sometimes notice increased hunger and stronger cravings for sugary or high-energy snacks. These effects reflect real biological changes rather than simple habits. One of the most fascinating findings from sleep research is how the brain compensates for moderate sleep loss. When sleep is shortened slightly, the brain attempts to preserve deep sleep stages. It compresses lighter sleep phases and prioritizes the most essential recovery processes. This adaptation helps explain why someone sleeping 6 hours may still function reasonably well. The brain is trying to protect its most important maintenance systems. However, this compensation has limits. Over time, even small nightly deficits can accumulate into what researchers call sleep debt. Sleep debt develops when the brain repeatedly receives less sleep than it biologically requires. Unlike acute sleep deprivation, this form of sleep loss builds gradually. A person may not feel dramatically exhausted, but mental performance slowly declines. 6 hours of sleep often sits exactly at this boundary. It may be enough to keep someone awake and productive in the short term, but over weeks or months, the brain may still be operating slightly below its optimal recovery level. This is why many people who sleep 6 hours report a familiar pattern. They feel functional during the day, but not completely restored. Energy fluctuates more easily, concentration sometimes fades earlier than expected, and mental clarity may not feel as strong as it could be. For some individuals, 6 hours truly may be enough. Human sleep needs vary depending on genetics, lifestyle, and circadian rhythm patterns, but for many adults, optimal cognitive performance occurs closer to 7 or 8 hours of sleep. The extra hour often allows the brain to complete the final sleep cycle that supports emotional processing and cognitive integration. And sometimes that final cycle is exactly what the brain needs to move from partial recovery to full restoration. Because in sleep science, the difference between 6 hours and 7 hours is not just 60 minutes. It can represent the difference between a brain that is coping with recovery and a brain that has actually completed its nightly reset. Another factor that makes 6 hours of sleep so deceptive is how gradually the brain adapts to reduced recovery time. When someone first begins sleeping less, fatigue can feel obvious, but after several days, the brain begins adjusting its perception of alertness. This adaptation can create the illusion that 6 hours of sleep is completely sufficient. In reality, what often happens is that the brain lowers its expectations of performance. Tasks that once felt easy may begin requiring slightly more effort. Concentration during long conversations, reading, or complex thinking may feel just a bit more demanding. Because these changes develop slowly, many people assume they are simply normal parts of daily life. But when sleep duration increases again, many individuals notice something interesting. Mental clarity improves. Reaction time becomes faster. Ideas feel easier to connect. This sudden improvement reveals how much the brain had been compensating while operating with limited recovery time. Another interesting effect of sleeping 6 hours regularly involves creativity. REM sleep, which becomes longer toward the end of the night, helps the brain combine distant ideas and detect hidden patterns between pieces of information. When the last sleep cycle is shortened, the brain has fewer opportunities to reorganize these connections. As a result, creative thinking and complex problem solving may become slightly less efficient. The brain still functions, but it may not reach its full potential. This is why sleep scientists often describe sleep not only as recovery, but also as preparation. During sleep, the brain prepares itself for the cognitive demands of the next day, and sometimes the difference between feeling mentally average and feeling mentally sharp is simply one additional sleep cycle. For many people, that extra cycle begins somewhere between 6 and 7 hours of sleep, which means that even a small increase in nightly sleep duration can have a surprisingly powerful effect on how clearly the brain works.